Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0108 refers to a high voltage condition detected in the Manifold Absolute Pressure MAP sensor circuit of the Honda Accord models produced between 2012 and 2017. This issue typically arises from the MAP sensor itself or associated components, which measure the pressure or vacuum in the intake manifold. The MAP sensor plays a crucial role in engine management as it communicates with the powertrain control module, PCM, to optimize air-fuel mixtures for efficient combustion. When voltage levels exceed predetermined limits, the PCM identifies this anomaly as a malfunction and subsequently triggers the DTC. Understanding this diagnostic code helps in pinpointing issues that may impact vehicle performance and fuel efficiency. The MAP sensor's location is typically near the intake manifold, ensuring accurate pressure readings for the engine's operation. To prevent issues leading to DTC P0108, implementing a regular maintenance routine is vital. This includes regular inspections of the MAP sensor to ensure it is securely mounted and free from debris that may interfere with its operations. Monitoring the integrity of the wiring connected to the MAP sensor is essential to avoid premature connector wear or corrosion. Performing periodic engine diagnostics helps in early identification of emerging issues, potentially avoiding major repairs down the line. Using a diagnostic scan tool to read codes during routine maintenance can help recognize faults before they escalate into significant problems. Proper care and timely checks on these components will maintain vehicle performance and longevity. In conclusion, understanding the role of the Manifold Absolute Pressure MAP sensor is essential for effective engine management in the Honda Accord models from 2012 to 2017. The activation of DTC P0108 indicates high voltage in the MAP sensor circuit, requiring methodical troubleshooting to identify the root cause accurately. Following the detailed troubleshooting steps ensures all potential failures, from sensor and wiring issues to PCM malfunctions, are considered. Regular maintenance checks can prevent issues from arising, thereby enhancing vehicle reliability and performance. By remaining proactive, vehicle owners can minimize the chances of encountering the DTC P0108 again, preserving their Honda's efficiency and operability. The components affected by the DTC P0108 primarily include the Manifold Absolute Pressure MAP sensor and the Powertrain Control Module, PCM. The MAP sensor is responsible for sensing manifold pressure and converting this mechanical measurement into an electrical signal. This signal is essential to calculate engine load, affecting fuel injection and ignition timing for performance. The PCM utilizes this information to manage engine functions effectively. Notably, erroneous signals from the MAP sensor can lead to poor engine performance, increased emissions, or even damage over time. Generally located near the intake manifold, the MAP sensor must be intact and properly connected to function correctly, ensuring accurate readings that the PCM relies upon. Several possible causes can lead to the activation of DTC P0108. First, an open condition in the MAP sensor PB line can disrupt the necessary voltage supply, inhibiting sensor function. Second, if there's an open in the MAP sensor SG line, the PCM would fail to receive crucial signal voltage, again triggering this DTC. Thirdly, a failure within the MAP sensor itself may result in incorrect voltage readings, prompting the PCM to signal a fault condition. Lastly, internal circuit failure within the PCM can also result in erroneous DTC reporting, complicating diagnosis. Though these causes are widely recognized, it's essential to conduct thorough diagnostics, as other, less common issues might also exist. The symptoms associated with DTC P0108 can significantly affect vehicle performance and driver experience. Notably, the malfunction indicator light, MIL, will illuminate on the dashboard, indicating a problem that needs attention. In some cases, drivers may experience performance issues such as stalling, reduced acceleration, or rough idling due to poor air-fuel mixtures. Furthermore, increased emissions can occur as the engine struggles to optimize fuel delivery under incorrect readings from the map sensor. Inconsistent engine performance may also manifest when the throttle is operated, particularly under changes of speed. Being aware of these symptoms helps in identifying issues early, encouraging timely repair actions for optimal vehicle functionality. The first troubleshooting step related to DTC P0108 involves verifying the engine's start-stop button's functionality and ensuring the vehicle is in the on mode. This step is critical as the map sensor function is directly connected to the power buildup during engine operation. It's imperative to determine that the engine produces an adequate voltage supply, known as VCC, which must be stable for the map sensor to operate correctly. Conducting a visual inspection can reveal loose connections or damaged wiring that may compromise the sensor's performance. Ensuring these conditions eliminates basic operational failures from the diagnostics process, making subsequent steps more effective in identifying the fault. In the second step of troubleshooting DTC P0108, the focus turns to inspecting the wiring connected to the map sensor, specifically the PB power supply and SG signal lines. It is essential to test for continuity in both lines to confirm there are no breaks or shorts that might prevent correct signal transmission. Utilize a multimeter for accurate readings while measuring resistance levels, ensuring they fall within the manufacturer's specified range. Any discrepancies in readings may indicate damaged wiring that needs replacing. Addressing these wiring issues is fundamental, as signal interference from faulty connections could falsely trigger the DTC and complicate further diagnosis. The third troubleshooting step involves testing the operation of the map sensor directly. Connect a multimeter to the sensor's output and measure the sensor's output voltage under varying throttle conditions. Initially, at high vacuum, throttle closed, the voltage should be low, while the voltage should increase as the throttle valve opens and the manifold pressure drops. Comparing these measurements against the manufacturer's specifications is crucial to determine if the sensor is operating within acceptable limits. If the readings exceed the specified thresholds, the sensor may be malfunctioning and require replacement. It is essential to ensure accurate measurements, as faulty readings could lead to incorrect conclusions or unnecessary repairs. The fourth troubleshooting step focuses on inspecting the powertrain control module, PCM, for potential internal faults. Employing a diagnostic scan tool will help in retrieving additional trouble codes that may provide insight into any underlying issues impacting the map sensor's operation. Check for software updates or calibration concerns that could affect PCM functionality. Inspecting the connections to the PCM is also essential, as loose or corroded pins can lead to communication failures with the map sensor. If all preceding tests yield normal results, yet the DTC persists, the possibility of an internal PCM malfunction must be considered, warranting further specialized diagnostics or replacement. After completing the troubleshooting steps and implementing necessary repairs, the final repair verification stage is crucial to confirm that the issues have been adequately resolved. Start by clearing the Diagnostic Trouble Code, DTC, from the Powertrain Control Module, PCM, using a diagnostic scan tool. erasing historical fault entries. Following this action, restart the engine to ensure that the PCM can begin normal operation without the fault being reintroduced. It is advisable to perform a drive cycle consisting of a variety of driving conditions to allow the PCM to run its diagnostics. Monitor the PCM for any return of the DTC or malfunction indicator light (MIL) illumination during this phase, confirming that repairs have restored proper functionality to the MAP sensor system. Please like and subscribe to the channel. See you next time.